Hello everyone. Today we will be presenting our project work, which is designing an airfoil using the software called Xfoil. Here in the windows, we need to first type the Naca airfoil, and our choice of airfoil is the Naca 0012. Here you can see the details of the airfoil. Then we need to type the command gdes, and here you can see that the airfoil presented in a separate tab which will come up. To add a flap, we just need to write flap, and firstly we need to add the hinge location, which for our case will be 0.7 along the x-axis. Then we need to add a hinge along the y-axis, and since we need to keep it symmetric throughout, we will just type 0, which is the axis of symmetry. After that we will add the deflection angle, and as mentioned, positive is downward, so we will add plus 15. Now we can see the new airfoil, which is going to be highlighted in purple. Now we need to type the command exec, which will set the highlighted airfoil to be the original airfoil that we will be working on. If it is not set to be the original, the new data will not be saved. Finally, to save the document, we will need to hit enter and type the command psav. This will prompt us to write a name for the file, and we will have chosen to go with the airfoil Naca 0012 underscore 15, and in this case it will automatically get saved.
Yes, so now we will move on to console, this is the CFD software that we use to compute and analyze file. So the first thing is you have to click on the model wizard, 2D, and dropping down to fluid flow, we have the single phase flow. We'll choose turbulent flow because that is in our specification, and you can see there is a lot of options. But we will go with turbulence flow SST because we have a higher Reynolds number. We will add it, and upon adding, we will move to study, and we will select the stationary with initialization option, and done. Now you can see that we have different tabs which will allow you to make changes and develop your product and design, and you'll have all these options that will help you to analyze and study your project. So the first step is to import uh, the airfoil. So we will go to geometry, we'll choose primitive, polygon, and from the data sources we will choose file and browse the file. You can see that we have a text file for 0 degrees, but we will be studying the positive 15 degrees flap, and this must be in text file. Open it and build selected. So once you click build selected, you will have the airfoil presented in the graphics tab. Now the second step that we need to do is to build a rectangle around it to imitate it as the air tunnel. So to do that, we'll go to primitives, rectangle. We will choose the width to be 1.6 and the height to 1.2, and the base must be from negative 0.3 and y negative 0.6. So we build selected, and zooming out, you'll see that your air tunnel has been built across the airfoil. But one thing we need to do is that we need to subtract the airfoil from the wind tunnel, from the air tunnels. So how to do that is to go to Boolean and select the difference tab. What this allows you to do is uh, to keep the design that you require, and to remove the things that are not wanted. Why we do that is to study across the airfoil boundary. So I will keep the air tunnel, and I will remove the airfoil. and bill selected. What this does is that it allows my air will flow through across the air tunnel, and it will analyze the airflow across the boundaries. And after I've bill selected, now moving on to parameters, you will have name, expression, and value. So there are three parameters that we will be using. The first is the chord length, the velocity, and the density. So the velocity U underscore INF and RHO INF are the functions of the console. So let us define it. C will be 1 meter. Um, U will be um, 50. We have chosen 50 meters per second for our application. 50 meters per second for our application, and RHO, and this will be 1.225 density kilograms per meter cube. Yes. So since we have defined our parameters, now we have to choose the materials for the wind tunnel. So to add the materials, right click and you can see that add materials from the library. We have the built-in materials as air. I'll double click it and I have the air that is present over here. All the datas. You can see the density and the dynamic viscosity are also present. And these are the different parameters that you can use for the from the air, the values. And now we will go to defining the inlet and the outlet of the air tunnel. So right click, we'll have the inlet. We will select the inlet to be in this position. Now the initial velocity of the inlet will be the parameter that we have chosen, INF. The parameter that we have chosen, that will be our initial velocity, and the outlet will have the pressure, which will keep it as 0. Now yes, now now we will move on to meshing the to create a mesh around the airfoil. So we have element sizes. So for this project, we'll go with fine elements size. So now selecting build all. After we have created the mesh, now I will move on to study and we'll click on compute. This might take a while for us. It will take maybe 1 or 2 minutes for it to load. So now our velocity profile and the pressure profile is present. As you can see that uh, according to the scale towards the red spectrum of the scale, it is a higher velocity, and towards the blue spectrum it's lower. So you can see in this design that the bottom of the airfoil in the front and in the back, they have a low velocity, and at the highest at the top we will have greater velocity profile because of now moving on to the pressure. You can see there is a greater pressure at the front and low pressure at the top over here. So to understand it better, you can just add a surface and plot it. You'll see that you have a better view of the pressure profile. And now we will have to find the lift and drag coefficient, which is why we will go to derived values, integration, line integration, And in this line integration, you have to select the bound or as all boundaries, but you have to remove the tunnel boundaries and only keep the airfoil boundaries that you need to analyze. Now, in the expressions section, you have to add the formulas. What you need to do is these are the two formulas that you will be using, stress Y and stress X. Stress Y will be the lift coefficient and stress X will be along the x-axis will be the drag coefficient. So I'll just copy and paste it and the unit will be 1. Copy and paste both of the equations and evaluate. So we can see that our stress Y, which is the lift coefficient, is 1.1092 and the drag coefficient is 0.044070. And since lift will be greater than the drag, uh, so these are the values that this is the assumption and hypothesis that we have stated is that the lift must be greater than the drag coefficient and it is validated with the console. Thank you so much.